Hey everyone, this is lesson 26, and today we're talking about the division algorithm. So really, what are those specific steps that you follow in order when you're doing any type of long division work? Don't be fooled though, we're not doing like third and fourth grade math work today. We are going to spend a few minutes just reviewing those steps, and then we're going to be applying them to more advanced division work. As we scroll down and take a look at your learning targets for today, you can see we're going to be using the division algorithm to divide 3-digit and decimal numbers by a 1-digit number. So we're talking about what happens when the dividend, so that number inside of the division box, when the dividend either becomes large enough where it's 3 digits or more, or it's a decimal number, it has a decimal in it. What do we do then? What are the specific steps to take then? And then, as with any division work, checking your answer to a division problem, that's called a quotient, by multiplying and then adding the remainder to the product. The product is your answer when you multiply. So you can always check any answer to any division problem by doing the inverse operation, which is multiplying. Scrolling down here, these are just typed out step-by-step directions on how to do the division algorithm. I will be attaching these notes, so those will be helpful to review, but I'm actually just going to model step-by-step how to work through one of those problems. I find that more effective or more helpful. Let's take a look at this first example. The school bought 3 printers that cost the same amount for a total of $852. What was the price of each printer? So let's start here. First of all, understanding which number goes in which place for this division problem is really important. So which one is going to be the dividend? Which one is going to be the divisor? Go ahead and get this set up and try this problem on your own. And when you are ready to check your answer, please unpause this video and I'll walk through step by step how to solve. All right, so I've worked out this problem. I just want to walk you through step by step on how I solved to get my quotient here. So I started here by asking myself, can 3 go into 8? Or is 8 divisible by 3? Yes. The closest we can get is 2 times. So 3 times 2 is 6. That's the closest we can get. 8 minus 6 leaves us with 2. Once I have that 2 dropped down there, it's time for me to drop down my next number because we have a new space to fill here. So I'm going to drop down my 5. And now I'm asking myself, well, can 3 go into 25? Not just 2, but 25. Well, yes, 3 can go into 25, and I determined 8 times was the closest that I could get because I know that 8 times 3, and I drop this all the way down here, is 24. So 8 times 3 is 24. Now I have 25 minus 24, and I have 1 left over, just my 1 right here. But I have another space left to fill here, so I drop down my 2. And now I'm asking, can 3 go into 12? Yes, it can go in evenly. 3 times 4, I didn't even finish this work. 3 times 4 is in fact 12, which leaves me with 0. And that's how I know I'm done. So going back up here, this is not how I should leave my answer. This was a story problem that asked about, oh boy, the cost of printers. And so what was the cost or what was the price of each printer? $284. This dollar sign right here is your label, and it's very important. I'll point out too, I had just put this decimal here at the end. That's where $852 is the same as $852 and no cents. I didn't end up with any change left over. It was an even $284 for each printer. So my answer could look like this, just $284, or I can do my decimal with 2 zeros. Both are correct. Let's move on. Oh, checking my answer. So really important with any any division work is to check your answer using that inverse operation or opposite operation, which would be multiplication. So in order to check our work, what we do is take our quotient and multiply it by our divisor on the outside. So we're going to take 284 times 3. And if that answer ends up being 852, our math was correct. So let's do that. 284 times 3. Go ahead and pause this video, solve that multiplication, and unpause when you're ready to check my multiplication with yours. All right, there you can see when I did this multiplication problem, my product ended up being 852. Just to double check, 852. So we're all good. Let's try another example. A group of teachers is planning a field trip for 234 students. The students will travel on 5 school buses. Is it possible for each bus to carry the same number of students? So go ahead and get this problem set up, understanding which number is going to be your dividend, which one's your divisor, and go ahead and try this problem. Unpause the video when you're ready to check your work with mine. Before I actually walk through and do any of this math, I feel the need to point something out to you. Good mathematicians are always looking for shortcuts. They're always looking for patterns. They're looking for faster ways of solving things. So ultimately, this problem is asking us. So what's the last question in here? Is it possible for each bus to carry the same number of students? That's what they're asking. I know that they actually want us to do the math and solve how many students are going to ride on each bus. I know that. It's good practice. But if this truly were a yes or no question, we should be able to solve that in our heads just like that, understanding the divisibility rules of the number 5. So taking a look at first glance, 234 students, 5 buses, is 234 divisible by 5? You should know by now, no, it's not, because numbers that are multiples of 5 either end in 5 or 0. That's it. This ends in a 4. So no, either way, one of the buses is going to have fewer students. So just take note of that. Something you should pick up on. Good mathematicians do. Now, please pause your video and solve, and unpause when you're ready to check your work. All right, so there are a few things that I actually want to talk about with this problem. I like this problem a lot for a few different things that you should know about division. First of all, I'm going to walk through my work really quickly. I'm going to zoom in a little bit closer. All right, so can 5 go into 2? No. Can 5 go into 23? Yes, and I said that was 4 times. 4 times 5 is 20. 23 minus 20 left me with 3 left over. I still have a space left to fill, so I'm going to drop down this 4. Can 5 go into 34? Sure. The closest we're going to get is 5 times 6, so I wrote my 6 up there. 6 times 5 is 30. I end up with 4 remainder. I have no more spaces to fill here, so 4, I have nothing else to bring down at this time. 4 is my remainder. So ultimately, my quotient or my answer to this division problem is 46 remainder 4. But I just want you thinking about something. Again, good mathematicians start to do this. Earlier this year, we talked about division answers and when it's appropriate to have a remainder, and sometimes it's just not appropriate to have a remainder. So if you were the head of transportation for a school district, you wouldn't say we need 5 remainder 2 buses to go on the field trip tomorrow. It doesn't make sense. So really, good mathematicians stop and ask, is this answer reasonable? Does this make sense? And you really kind of have to dissect what this means. 46 remainder 4 means every single one of those 5 buses lined up has 46 students on it. But then there are a remainder of 4 students left over standing there on the sidewalk that haven't gotten on the bus yet. So every bus has 46 with 4 remaining students. So that means that we can divide those students, 1 student on the 4 of the buses, meaning 4 of the buses are now going to have 47 students. And that last bus, that 5th bus, will still only have 46. So just kind of understanding what your quotient is telling you is important with word problems or story problems. Checking with a remainder. So here again, we're going to multiply to find out if we did our math correct, to just double check our answer. Oh, my lights just shut off. So bear with me. I'm going to pause the video here. Please do this work. We're going to take our quotient. So we're going to take 46 times 5 and add our remainder. Hopefully, when we do that, we're going to get 234. All right, so you can see here I've done the multiplication work. I did the 46 times 5. I ended up with 230, and then I added my remainder. I added that 4 those 4 left over, and I came up with 234. So good. Our math was correct. Taking a look at a problem that looks like this. I love problems that look like this because they look intimidating, right? I like talking through them because really they're not as scary, not as difficult as they look. Also, this really gets our brains ready to start looking at algebraic expressions. So really what we're looking at right now is, this is algebra. This is an algebraic linear expression, but also it's just a division problem. It's just a matter of how we're looking at things, or a multiplication problem. It's how our brains are looking at these. Here's what I want you to take a look at. Really, the way that we would read this is 5n equals 365. Here's another way to think about this that might not seem so intimidating. We know that in math, anytime a variable, meaning any letter, unknown number, is right next to a number, that means we're going to be multiplying those together. So instead of putting an n there, you can just put like an empty box or a question mark. Really what this is asking is 5 times what will give us 365? 5 times what? 5 times something. Sometimes even just writing that out helps people see it where it's not so intimidating. Something like this. 5 times what is going to give me 365? But really anytime we're thinking about, so this is set up like a multiplication problem. The inverse operation of that is division. And another way to think about this, and some of your brains will just automatically do that, is understanding that in order to solve for n, or in order to solve for this empty box, oops, wrong way, where is it? There, my camera's backwards. In order to solve for this box, right there, okay, that's kind of weird, it's backwards. We need to divide 365 divided by 5, and that's going to give us our variable, our missing variable n. I might, if time allows, I don't like these videos to get too long, but I might even walk through just kind of an algebraic way of solving this. So please pause this video, do that division work, and unpause when you're ready to check your work with mine. All right, so I'm just going to talk through some of my work. I've moved my camera of my face just up to the top of the screen just to allow me some more workspace right down here. But to walk through the division first, I have, can 5 go into 3? No. Can 5 go into 36? Yes. 5 can go into 36 7 times. 5 times 7 is 35. 36 minus 35 left me with 1, but I still have a space left to fill here. So I'm going to drop down my 5. Now I have 15 here. Can 5 go into 15? Yes, and it can go in evenly. So that's 3 times. So I bring up a 3 here. 3 times 5 is in fact 15. 15 minus 15 leaves me with 0. It means I'm all done. So as a quotient here, I got 73. And I went ahead and I just jumped right into doing the multiplication, that inverse operation to check my work. Right over here, I took 73, so my quotient, times my divisor. So 73 times 5, and then I got 365, ensuring that I did my math correct. So our answer was right. I just want to point out, I can't help myself because I love algebra. I want to point out just a way of thinking about this like algebra. So once we start doing that work, you won't do that with me, I wish, but really like in 7th grade or higher. We're asking 5n equals 365. The point in algebra is always to get a variable by itself. So we need to get this n by itself. In order to do that, we need to do the inverse operation to get rid of the number touching it or right next to it. So right now 5n means 5 times n. The opposite operation of that, or the inverse operation, would be divide. So we would, oh, I lost my pen. We divide by 5, canceling that out. And whatever I do on the left side, or whatever I do on one side of the equal sign, I have to do on the other side. So if I divide by 5 on this side, I have to do the same over here. So take a look at that. Now I have, our ultimate goal is to get the variable by itself. Now I have n by itself. I have n equals 365 divided by 5. Look at that. It's exactly what we just did. And when we do that math, we find which we just did, we have n equals 73. That is the most, the highest form of your answer that you could put for this problem, the best possible answer using anytime you have a variable in a problem, it's best to use that as your label, because as you advance in your math, you will be working with expressions that have multiple variables, like maybe an n and an m. And so just really getting in the habit of labeling your answer with that variable is a really, really great skill to lock in your head, because then you can identify which variable is which number. So n equals 73. Okay, one more example here. 3 students collected aluminum cans and were paid $8.85 by a recycling center for these cans. The income is to be divided equally. So equally, we're going to be dividing how many students? 3. Okay. What amount should each student receive? So we're dividing this amount of money out by 3 students. Go ahead and set this up, solve, and unpause the video when you're ready to check your work with mine. All right, so just walking you through my work here, I've set up the $8.85 divided equally amongst 3, I think it was students, 3 students. So can 3 go into 8? Yep, the closest we can get is 2. So 2 times 3 is 6. 8 minus 6 leaves us with 2 left over. I have another space left to fill here. So I'm going to bring down my 8 all the way down here. Can 3 go into 28? Yes. Closest we can get is 9. So 9 times 3 is 27, I've written here. 28 minus 27 left me with 1. I still have another space left to fill here, so I'm going to bring my 5 all the way down. Can 3 go into 15? Yes, evenly. So 3 can go into 15 5 times. 5 times 3 is in fact 15, which leaves us with a remainder of 0. One thing I should have pointed out right at the very beginning is anytime, this is really, really important, anytime your dividend, this number in the box, has a decimal point, anytime it's a decimal number, that decimal moves straight up. So that could have been my first step right there. Decimal moves straight up. So here we go. We have $2.95. That's why that decimal is there. I did that. When I was doing this work by myself, I did that right away. So $2.95. I went ahead over here and did the inverse operation, the multiplying, just to double check my work. I took that quotient of $2.95 and multiplied it by my divisor of 3, and I got $8.85, which is what I was hoping to get. I knew my answer was correct, so I wrote my answer down here, $2.95, and of course I wrote that with a dollar sign. Anytime you're working with money, it's really, really important that you put your decimal and your dollar sign there, or your cent sign. That's your label, and it's really important. That's it for practice today. It was quite a few things to practice. Doing work with division isn't going to go away. You're going to use it the rest of your life for a billion reasons. So it's good to get a lot of this practice in, get comfy with it. I'm confident that really, if you can really grasp the steps of the division algorithm, you'll be able to successfully move forward with your division work as it gets more and more complex.